Alright, so I'm going to go back over this plotting out the titration curves and everything. Hopefully this will be a lot more simple than the previous two videos. Some students have come to me experiencing some problems because their data didn't match up exactly the way I anticipated, so I kind of took their concerns in mind and revamped my video. So, where'd that go? Here we go. So we're going to be able to do this in 8 easy steps. First, just plot the milliliters of sodium hydroxide versus the pH. Then calculate the slope using the equation given. That's this guy down here. Plot the milliliters of sodium hydroxide versus the delta pH over delta V. That's this. Determine the equivalence point from the plot made in 3. Plot lower points of the pH curve on the plot made in 1. And fit line to lower points. Use the equation determined in 6 up here to determine the pH 50%. And then finally use the pH 50% to determine the Ka. Yeah. So the first thing you want to do is just plot out your pH curve. So here on the y-axis we have the pH of our solution versus on the x-axis we have milliliters of the sodium hydroxide added. So you should get something like this. So this is a very good example where we don't have a lot of data points here in the center. We didn't extend too far. Okay, if you extend way far out here, it's not a big deal. Don't worry about it. So the first thing we want to do is, or the second thing we want to do is calculate the slope using the given equation. So in this equation is just the first derivative or the slope at any one of these given points. Okay, so if we took the first derivative of each one of these points, the equivalence point will be the point on this curve where the slope is the greatest. Okay, so just keep that in mind. So if you see here, I have 3 data points: pH1, pH2, and pH3. So this is not just 3 random points. This is in sequence. So the first point, the first delta pH delta V value is going to be pH1, pH2, pH3, and then the second delta pH delta V will be pH2, pH3, pH4, etc. Okay? Same with the volumes. So the reason we're doing this is because if we just did the difference between pH2 and pH1, for example, divided by volume 2 and volume 1, we wouldn't have a volume. That would give us a slope that was corresponded to a volume in between volume 2 and volume 1. We want a slope that's comparable to a measurement we made, and so taking these averages of pH3 and pH3, pH2, pH2, and pH1 will give us a slope that's directly comparable to volume 2. Okay, so I'm going to break this up into 3 columns here. So the first column I'm going to do delta V. So, and again, delta V was just volume 3 plus volume 2 divided by 2 minus volume 2 plus volume 1 divided by 2. Okay? So I just click on this cell and there's this little blue box right here. You just want to put your cursor over that until that black cross shows up and drag that over one space. We'll call this delta pH. So what that's done is now that's copied that same equation over for the pH values. Okay? And then our delta pH divided by delta V is just D divided by C. So we don't have to type that in each time down here. All we have to do is select all of these columns, put our cursor over the blue box, and click and drag all the way down to here. Okay, the reason why I didn't do the last, actually I can do the last 3. There we go. Reason why I didn't do the last, these last 2 points is because there's not a third value in each of these sets, so it wouldn't give us a real number. Okay, so that honestly is the hardest part of this whole thing. So now what we want to do is plot this column on the y-axis and this column on the x-axis. So we just click somewhere out in space here, go to Insert, add a new chart. I'm just going to do a scatter plot. Going up to add a new series, click this to minimize it. So then for the x values, we just want to select all of our milliliters, and then for y values, we just want to select all of our slopes. We just go through some formatting options. I don't like to show a legend, and I don't like to see grid lines. So the x-axis here is milliliters of NaOH, and the y-axis is delta pH divided by delta V. And there we have it. That looks really good. One thing I like to do is double click on this, just anywhere in this area, and get rid of this fill, make it no fill, and get rid of this line. That'll save you a lot of ink when you go to print things off. So look, here we have a peak. And so what this tells us is this says 22.5, 7.4. So that means the slope is 7.4, that's our highest slope, and that occurs when we've added 22.5 milliliters of sodium hydroxide. So this is our equivalence point, and that corresponds to this point right here. Now, that would be a lot closer to the actual equivalence point if we had more data points in here, but this way is actually a lot better. It's a lot more systematic than just eyeballing. You want to try to be as objective as possible. Eyeballing it would be very subjective. We know this will have some error in it, but at least we know we can gauge the error. It's not really important. So we know our V 100%, our equivalence point, is 22.5 milliliters. So then we know our V 50% is just half of that. So that's 11.25. So there, we found the equivalence point, really easy. Oh, so we've done 1, 2, 3, and 4. Okay, so I'm going to break this up into 2 videos, and in the next video we'll just do 5, 6, 7, and 8.